In this video, I'm going to go through a view an example problem that comes with one of the problems from your homework. So take a moment to pause and read the full problem statement and take note of the drawing over here. So one of the things that we're asked to do is to rewrite this volume function as a function of x. And the hint that we're given is to use the similar triangles. So that information is explained here. And if we look at this illustration closely, what we see are two similar triangles, which I'll highlight over here. I've just copied and pasted those same things. So let me get my highlighter. All right, so we have a similar triangle. Let's see here. It's just not a thick highlighter right here, okay? But I have this triangle legs, H and R, and then I have this similar triangle over here. Again, just not a very thick highlight right there, with H minus H, well, upper and lowercase, and it's lowercase r, which is also equal to 9x. So that's why we have this statement. We're making a statement of proportion with similar triangles. Next, what's in the problem is some algebra. So it says to solve this equation for the height lowercase h. And I'm going to try to follow through these steps that are listed in View an Example, but show some of the work that is missing in this View an Example problem. So remember, our goal here is to solve for lowercase h, and I see it located here and within the equation. So one of the first things I can do is multiply both sides by 9x. So I'm going to show that work over here. So multiplying by 9x, we get 9x h over r equals capital H minus lowercase h. Okay, I'm going to go back and notice that that's the same thing that they have here. The terms are in different orders, but since we're all multiplying, that's okay. So to get h by itself, it looks like they're moving this term capital H. So to move that term, there's a couple of ways you could think about this, and a couple of steps are happening here at once. I could subtract h from both sides, capital H. And then multiply everything by -1. Now, multiplying everything by -1 means that both of these signs here are going to change as well. So this becomes negative, this becomes positive. And if I check back with View an Example, notice that they choose to list the positive term first. We could have written negative 9x and so forth and so on, and then plus h, or you can write the positive term first, and that's what they're doing there. So when I look back at View an Example again, I see that all of a sudden both of these different terms here have the same denominator r. So that's the next step that we're going to do in our scratch work, is we're going to write a common denominator r by multiplying this term by r over r. Okay, that gives us hr over r minus 9xh over r equals lowercase h. I can then combine those two by subtracting those numerators. And I see one more thing that happened over here was they have this expression factored from its numerator. So if I look at the common terms or common factors that these terms have, they both have a common factor of capital H. So I'm going to write that capital H out. Let me move this down just a little bit more here for some space. I'm going to factor that out, and I'm left with r minus 9x over r equals h. And if I come back and check here, notice that's the same thing that they have as an expression for h. So continuing, now we're going to take these expressions for lowercase r and lowercase h and substitute them into the volume formula, and that's what's happened here. So I also took a screenshot of that over here because in the very end we want to simplify that expression. So again, a little bit of algebra happening at this point. We have that the volume equals, and I'm going to jump to this expression for volume. We want to square the 9, square the x. We also would multiply by h times r minus 9x over r. And checking back with our expression here, the only thing differently they did was they moved some of the terms around. We have all the terms in place at this point. And I'm going to actually scrunch this down just a little bit so we can see how they compare. So 81, capital H, and pi, and even, well, I could put the x squared there. I'm not exactly sure why they didn't put the x squared there, other than the x squared is a variable. But taking out all of these terms that are constants, we can put them in the front. You see that's what happens here. And then the next term contains an x. So that's the variable x, right? And then the last term would be, or last factor, I'm sorry, I shouldn't say term. Last factor here is that x squared piece. So that's why we're rearranging. We can take all those constants, the 81, pi, capital H, and the r. Okay, that takes care of 1, 2, 3, 4, all these. Next, we have this expression that contains a variable. And then last, we have this expression that contains a variable. So just a reorganizing at that point.